Hello again. Welcome to Engineer's Mindset. Alright, so let's consider the question on the board. We have f of x, y, z equals x squared, y squared, I plus tan inverse of x over yj plus sine inverse of x over yk. So this is actually a vector function. Okay, and we are giving this function inverted triangle of this function f, x, y, and z. We're asked to find this. Alright, so this actually doesn't mean anything big. This inverted triangle simply means, this actually means that you should simply find the partial derivative of this function with respect to x, find the partial derivative of that function with respect to y, and also find the partial derivative of that function with respect to z. So this is all we have to carry out in this question and nothing much. Okay, so I have a triple addition function here. So just like in the previous video, I will simply say let a, just to break it down in bits, let a be simply x squared, y squared, okay, and b to be equal to tan inverse of x all over y, and c to be equal to sine inverse of x all over y. So I'll simply have this. So if I'm saying this, it means now that this function f of x, y, z is now equal to, in place of x squared, y squared, I call that a. So I'll simply have a to I, okay, plus in place of tan inverse, I call that b. So I'll simply have b to j plus, and in place of sine inverse, I'll simply call that c. It becomes c to k. So like I always say, the derivative of a sum is actually the sum of the derivative. So what that simply means is, if I differentiate this function with respect to x, it's actually equal to partial a all over partial xi plus partial a plus partial b all over partial xj plus partial c all over partial xk. Also, if I differentiate this function with respect to y, it becomes partial f all over partial y, and that's also equal to partial a all over partial yi plus partial b all over partial yj plus partial c all over partial yk. And same thing with z. If I differentiate that function partially with respect to z, it also becomes partial a over partial zi plus partial a over partial zkj, partial b, okay, plus partial c over partial zk. So I'll simply have this. So this is all the equation is saying: differentiate the function with respect to x, with respect to y, and with respect to z, and that is all we need to get. Okay. So let's start from a now. A equals x squared, y squared. Okay, from a equals x squared, y squared. Let's differentiate a partially with respect to only x. So from the law, if I'm differentiating partially with respect to only x, it means I'm going to treat y squared as a constant. So I'll simply hold y squared and differentiate only x squared. If I differentiate x squared, simply use the power of x, 2 to multiply x, then subtract 1 from the power, 2 minus 1. I will have this. And this is actually equal to y squared into, it becomes 2x to the power of 1. 2 minus 1 is 1. Therefore, the partial derivative of a with respect to x is equal to, this is simply 2xy squared, okay? 2xy squared. So this becomes partial derivative of a with respect to x. All right, so next is to differentiate b. Let's try to achieve this first equation. So next is to differentiate b with respect to what? X. From the first equation, differentiate b with respect to x. So from b equals tan inverse of x all over y. I want to differentiate b with respect to x. The first thing I'll do, just like in the previous video, I'll give attach a single variable to what this function x all over y in front of the trig function. So I'll simply say let u be equal to x all over y. Okay, so this now implies that b itself is now tan inverse of u, because I'm saying the whole of this angle x over y should be called u. So it becomes tan inverse of u. From here now, it is clear that u is now a function of both x and y. So u is a function of x and y, and from here it is clear that b itself is a function of only v. B depends, sorry, of only u. Okay, so b depends on u to be defined. If I give any value for u, that will give me the value for b, so which means b is a function of u, and from here I can only give values to x and y to find the value of u, so which means u is a function of both x and y. But I want to look forward the partial derivative of b with respect to x, so which means I'm only going to differentiate u here with respect to x, because it's only u that can change, but I can only differentiate b with respect to u. All right, so from u equals x all over y, this can also be written as x y to the power of minus 1. If I want to differentiate u with respect to x, partial u all over partial x, okay, from the law, you keep y to the power of minus 1 as a constant, hold it as a constant, and differentiate x. And of course, if I differentiate x, I will simply have 1 to be the answer. So this actually means that the partial derivative of u with respect to x is actually equal to y to the power of minus 1. So you have that. Next is to differentiate b with respect to u. From b equals tan inverse of u. From b equals tan inverse of u, the partial derivative of b with respect to u will simply give us 1 all over 1 plus u squared. That is the rule. The partial derivative of inverse tan function is simply 1 all over 1 plus u. So you simply have this. Okay, but not forgetting, we said let u be equal to x all over y, which I said u can also be what? X y to the power of minus 1. So state that down, but u equals x y to the power of minus 1. So this implies that the b all over the u is now equal to 1 all over 1 plus, in place of u squared, we simply have x y to the power of minus 1 all squared. So we have this for the b du. Now, I'll find the b du, I'll find the u dx, but what I'm looking for is actually the b dx. So I'll simply employ the chain rule to find that value, which is that if I multiply these two derivatives, I'm going to obtain partial derivative of b with respect to x. Let's do it over here. So from chain rule, the partial derivative of b with respect to x is actually partial derivative of b with respect to u multiplies partial u with respect to x. So from here, partial u can cancel partial u. You're simply left with partial b all over partial x. And we've gotten these derivatives, we simply multiply them together. Partial b all over partial x is now equal to, let's obtain their values. So we have partial u partial x as y minus 1, and then partial b partial u as 1 all over this. Okay, so partial b partial u gave us 1 all over 1 plus x y to the power of minus 1 all squared. Okay, multiplied by partial u partial x gave us y to the power of minus 1. So this implies that the partial derivative of b with respect to x is actually equal to y to the power of minus 1. Of course, this times 1 remains y to the power of minus 1 all over 1 plus x y to the power of minus 1 all squared. So you keep this aside. So second part solved. We found partial b partial x. Next is to find partial c partial x. And we recall we said let c be equal to sine inverse of x over y. So we solve from there. Okay, so just to create space for myself on the board, I'll pull out partial a partial x and keep over here. So partial a all over partial x actually gave us 2x y squared. So all right, so we've gotten these two functions now. Next is to find partial c partial x. Let's do that over here. All right, so from c equal to, we said let's see the sine inverse of x over y. Sine inverse of x all over y. Same thing, we're still going to apply chain rule. So we simply assign this angle to be a single variable. So we can say let v be equal to x all over y. If you do this, this now implies that c itself becomes the sine inverse of v, because I've called this whole variable x all over y. So this now implies that c itself is sine inverse of v, okay, because I've said let x over y be simply called v. So just like I explained in the previous step, here simply means that v is a function of both x and y. V depends on both x and y, which means I can differentiate v either with respect to x or with respect to y, because it depends on the two variables. Also, this actually implies that c itself is a function of only v. C here depends on only v, and as such, I can only differentiate c with respect to v partially. Okay, so let's do that now. Let's obtain partial c all over partial v. Differentiating c with respect to v, the derivative of an inverse trig function for sine is simply 1 all over the square root of 1 minus v squared. So you have this. But v is actually x all over y, which can also be written that v is equal to x y to the power of minus 1. So this now implies that the partial derivative of c with respect to v is actually equal to 1 all over square root of 1 minus. In place of v squared, we simply have x y to the power of minus 1 all squared. Okay, because we said v is simply x y to the power of minus 1, and v here is squared. So you simply have this to be partial c partial v. So from v, now from v is equal to, okay, xy to the power of minus 1. We can now differentiate v. Since I'm looking for partial c partial x, it means I have to differentiate v with respect to only x and keep y as a constant. So partial v all over partial x is now equal to, so I will simply treat y to the power of minus 1 as a constant and differentiate x. If I differentiate x, I will simply have 1. So this simply means that partial v all over partial x is simply y to the power of minus 1. Alright, so having obtained this now, notice that if I multiply these two partial derivatives, I'm actually going to obtain partial c all over partial x. So that's simply the chain rule. So from chain rule, I will simply have that partial c over partial x is simply partial c over partial v multiplied by partial v all over partial x. So from here, partial v cancels partial v. I'm left with partial c all over partial x. Okay, so this means that partial c over partial x is now equal to, I obtain the value for partial v. I obtain the value for partial c over partial v, and that value is simply this. So partial c partial v is this, 1 all over the square root of 1 minus xy minus 1 all squared, okay, multiplied by partial v partial x, and that gives us simply y to the power of minus 1. Okay, so this now implies that the partial derivative of c with respect to x is simply equal to, of course, y to the power of minus 1 multiplies 1. I will simply have y to the power of minus 1 all over square root of 1 minus x y to the power of minus 1 all squared. So this becomes the partial derivative of c with respect to x. So we know partial a partial x, we know partial c partial x, we know partial b partial x. We can now form the first derivative, partial a partial x plus partial b partial x plus partial c partial x. Okay, let's do that and see. All right, so for that first function, partial f partial x all over partial x is now equal to, so we said partial a partial xi and partial a partial x give us 2xy squared. So we simply have 2x y squared I, attach your I to it, plus partial b partial xj, and partial b partial x give us this y to the power of minus 1 plus y minus 1 all over the square root of 1 minus, sorry, 1 plus, plus x y to the power of minus 1 all squared. Okay, and that's in j plus partial c partial xk, and partial c partial x give us this y to the power of minus 1 all over the square root of 1 minus x y to the power of minus 1 all squared in k. So this becomes the very first answer to the first partial derivative. So I said this function delta f or inverted delta f simply means differentiate f with respect to x, differentiate f with respect to y. So we've done partial f partial x. So next is to find partial f partial y. So let's do it and see. So I'm going to wipe the board now. All right, so the next mission is to find partial f partial y. So we simply differentiate each of these functions now with respect to y. So let's start from a. From a equals x squared y squared. I want to simply differentiate now a with respect to only y, which means I'm going to treat x squared as a constant, and that simply becomes x squared kept as a constant. I'm now going to differentiate only y. Y is raised to the power of 2, so use the power to multiply y. It becomes 2 times y. Remove 1 from the power of 2, 2 minus 1. Okay, you have this. So this simply implies that the partial derivative of a with respect to y is now equal to 2x squared y. Of course, 2 minus 1 remains 1. So you have that to be the partial derivative of a with respect to y. So you keep this derivative aside. Next is to differentiate b with respect to y. So from b equals tan inverse of x all over y. Okay, so what I will do here is this, like always, let u be equal to x all over y. All right, so if u is equal to x over y, this now implies that b itself is actually the tan inverse of u. So this means that u is a function of both x and y, which means I can try to differentiate u either with respect to x or with respect to y. And this also means that b is actually a function of only u. So b depends on only u to be defined, which means I can only differentiate b with respect to u. Now, this is actually called function of a function in calculus. When we have a function to be a function of another function, is called function of a function. I have b to be a function of u. Meanwhile, u itself is a function of x and y. So this is actually called function of a function. And the only rule which we can use to differentiate functions of function is simply what? The chain rule. Please keep that in mind. That's the only rule we can use to differentiate function of a function. Okay, so like I said, b now is a function of u, which means I can only differentiate b with respect to u. Also, u is a function of x and y, but now I want to differentiate b with respect to y. So which means I can also differentiate only u with respect to what? Y. Okay. Now, from u equals, of course, x over y can be written as x y to the power of minus 1 is still the same as x over y. The partial derivative of u, partial u all over partial y, differentiating u with respect to y, you keep x as a constant and then you differentiate y to the power of minus 1. So simply use the power minus 1 to multiply y minus 1, then subtract 1 from the power minus 1. So I'll simply have this. So this means that the partial derivative of u with respect to y is simply equal to, it becomes, of course, x times minus 1 becomes minus x y, then minus 1 becomes minus 2. So we have this for partial u, partial y. Next is to differentiate b with respect to u. So from b equals tan inverse of u, the partial derivative of b with respect to u from inverse trigonometric partial derivatives, we are simply going to obtain 1 all over 1 plus u all squared. But not forgetting, u is equal to x y to the power of minus 1 as said here. Okay, u is equal to x y to the power of minus 1. This now implies that the partial derivative of b with respect to u is simply equal to 1 all over 1 plus, in place of u squared, u is x y to the power of minus 1 all squared. So now, having known this now, the next thing is to find what? The partial derivative of b with respect to y. So I said if we have function of function, the only rule we can use is actually the chain rule. And of course, partial b all over partial y can be obtained by multiplying these two derivatives together, partial b partial u times partial u partial y. So we have partial b all over partial u times partial u all over partial y. So notice here, partial u can cancel partial u, so I'm simply left with partial b all over partial y. Okay, so partial b over partial y is simply equal to partial b partial u itself give us 1 all over 1 plus xy to the power of minus 1 all squared. We'll put that down, 1 all over 1 plus x y to the power of minus 1 all squared multiplied by partial u over partial y, and partial u partial y give us minus x y to the power of minus 2. So if we evaluate all that together, minus xy to the power of minus 2 multiplies 1, it gives us partial b partial y. Partial b all over partial y is now equal to, it becomes minus xy minus 2 all over 1 plus xy minus 1 all squared. Okay, so this becomes the partial derivative of b with respect to y. You keep that aside. Finally, we find the partial derivative of c with respect to y. So from c equals sine inverse of x over y. From c equals the sine inverse of x all over y. Okay, as always, let v be equal to the angle x all over y. Okay, so please take note, you can choose any alphabet you wish. You can choose any alphabet, just know your procedures and what you're doing. It doesn't matter, you can choose any alphabet. So this now implies that c is now the sine inverse of v, because I've said let v be the word x all over y, so it becomes c becomes sine inverse of v. So from here, it means that v is a function of both x and y, because v depends on both x and y, and also here c is a function of only v, so which means I can differentiate c with only v. And I've said if you have function of function, it actually means you're simply going to employ what? The chain rule to what? Evaluate this differentiation. All right, so from c, let's obtain partial derivative of c with respect to v. Since c is a function of v, it means I can only differentiate c with respect to v, and I will simply have this to be 1 all over the square root of 1 minus v all squared. This becomes the partial derivative. But v is equal to x all over y, which can be simply x y to the power of minus 1, still the same as x over y. Therefore, the partial derivative of c with respect to v is simply equal to 1 all over square root of 1 minus, in place of v, we'll have x y to the power of minus 1 all squared. So you have this. So this becomes partial c, partial v. Next is to differentiate v with respect to y. Okay, so I will take here off. All right, so from v equals x y to the power of minus 1, I will differentiate v now partially with respect to only y, which means I'm going to be holding x as a constant. So you keep x constant, differentiate y. To differentiate y, use the power to multiply y. The power is minus 1, it becomes minus 1 times y, then subtract 1 from the power, minus 1 minus 1. So I have this. So this now implies that, of course, okay, so this is actually x into, this becomes minus y, then minus 1 minus 1 gives us minus 2. All right, so partial v all over partial y is now equal to, it becomes minus x y to the power of minus 2. So we have this. So having known partial v, partial y, and we know partial c, partial v, we can now employ simply the chain rule to solve. So from chain rule, of course, we can obtain the partial derivative of c with respect to y as simply the multiple of those two derivatives, partial c over partial v multiplied by partial v all over partial y. Okay, so partial c over partial y is now equal to partial c, partial v actually gave us 1 all over root 1 minus xy to the power of minus 1 all squared. So we have 1 all over root 1 minus xy to the power of minus 1 all squared, okay, multiplied by partial v, partial y, and partial v, partial y gave us minus xy to the power of minus 2. So multiply by minus xy minus 2. And of course, minus xy minus 2 multiplied by 1. This now implies that the partial derivative of c with respect to y is simply equal to minus x y to the power of minus 2 all over the square root of 1 minus x y to the power of minus 1 all squared. So we simply have this. So this becomes the partial derivative of that function. So we know now partial a, partial y, we know partial b, partial y, and we know partial c, partial y. We can compute the second vector, partial f, partial y. Okay, let's do that and see. All right, so I will pull down partial a, partial y here, partial a all over partial y, so I can create space for myself. Is 2x squared y. Okay, let me take this side off now. All right, so the second vector becomes partial f all over partial y, and that's equal to partial a over partial yi, and partial a partial y give us 2x squared y. So we simply have 2x squared y I, okay, plus we have the next one, partial b over partial yj, and partial b over partial y simply give us this minus x y to the power of minus 2 squared all over that, okay, minus x y to the power of minus 2 all over 1 plus x y to the power of minus 1 all squared j plus the final vector is partial c over partial yk, and partial c partial y give us this minus x y to the power of minus 2 all over the square root of 1 minus x y to the power of minus 1 all squared. And of course, minus is stronger than plus, so we simply have this now implies that the partial derivative of that function with respect to y becomes 2x squared yi. Okay, sorry, this is I, please. Okay, now minus plus becomes minus x y to the power of minus 2 all over 1 minus x y to the power of minus 1 all squared j. Okay, same thing here, minus plus comes minus x y to the power of minus 2 all over the square root of 1 minus x y to the power of minus 1 all squared. So this becomes the answer to that vector. Okay, in K, so you have this. All right, so that becomes the second vector, partial f partial y. So you're left with partial f partial z. So I think I will leave this to you. Just try to lay your hands on it and see if you have any difficulty at all, any challenge. Don't forget to hit me on WhatsApp. My number is displayed on your screen, so I can see how to assist or help you out. But then I'll keep it here. Thanks, guys. I will see you in the next video. Please, if you're new to the channel, don't forget to tap the subscribe button to keep getting all updates when content as this and more engineering content keep dropping. I'll see you in the next video. Thanks and cheers.